So what we're trying to do is make minimally invasive, fully implantable optical biosensors that can be injected underneath the skin for management of chronic diseases. The way we do this is by taking polymer matrices. This is a polymer right here, polyhema, which is one of the main ingredients in contact lenses, and it's functionalized with a green dye. It looks green, but it's excited by red light, and it emits light back in the near infrared region. And the interesting thing about this dye is that it's a phosphor, it's a long lifetime phosphor, so we can measure the signal decay. You can see here. So this is where we would have a light source, such as a red light, because the dye is excited by red light. We turn on the light source, and it would excite the dye. Turn it off, and measure this decay here. And based off of using a curve fitting algorithm, we would get a value for this lifetime. And because it's a long lifetime on the order of microseconds, it allows us to eliminate the problem of autofluorescence that many people see in the skin, in the body, with these implantable sensors that are optically responsive. So you can see, if you look back at this sensor, that it's very small. The reason for this is because we want to insert it into a needle and inject it under the skin. And what you see here is a silicone patch, which looks like skin. It's got absorbers and scatterers in it that mimic the optical properties of the skin. So when we're making these sensors, we can put them under what we call a skin phantom. This is a skin phantom, and then put our puck-sized reader on top and check to see if we can see the sensor through the skin. So the ultimate goal is to be able to see the sensor through the skin using an optical reader such as this. So this is a prototype, and what it has is an LED and a silicon photo multiplier in it, and a thermistor as well, so that way we can excite the dye through the skin, collect the signal back, and also read temperature, because the signal will be affected by temperature. And so this is a prototype version, but ultimately we'd like something that could maybe fit on the back of a cell phone or something like that, or use a red light on the cell phone to be able to collect the signal back, and have an app that the patient could monitor their blood sugar with in an on-demand fashion. So there's applications in remote healthcare and sensing and chronic disease management, also Internet of Things, big data for healthcare. So that's kind of the ultimate vision for our project.
Great.